Hello, as promised, this video is going to go through three quite basic examples of how to use circle theorems within an exam question. Obviously, the questions can get way more complicated than these ones, but I just wanted to give you some basic examples so you can start wrapping your head around how you can spot them and how you can use the circle theorems within a question, okay? So I'm going to get straight into it. Here's our first question. We have a circle, we have some angles and lines and things in the middle of it. We need to find angle ABC and angle AOC using the circle theorems. So the first one, angle ABC, means we are trying to work out this angle here. Now, what we have in this diagram is a cyclic quadrilateral. So I'm going to highlight it so you can see where it is. So we have a four-sided shape where all four corners are on the circumference of the circle. So that is a cyclic quadrilateral. That means that angles opposite each other add up to 180. So we actually have two angles opposite each other, or we have one and we're trying to find the angle opposite. So we know this 109. We want to know the angle opposite it. So we know that it has to add up to make 180. So to find angle A, we are going to do 180 minus 109, which is 80. No, it's not. It's 71 degrees. I should have my calculator ready, but I don't. I've just realised. Never mind. Is 71. That is angle ABC. Our reason is because opposite angles in a cyclic quadrilateral sum to 180. Because opposite angles in a cyclic quadrilateral, I'm just going to write quad, sum to 180. Okay. Obviously, the question hasn't specifically asked for our reason, but if it did in an exam, that is what you need to write. I might not do that for all of the questions, purely because you don't want to sit and watch me write on the screen. But in an exam, it could ask you to give a reason, just like it does for an angle question. Give a reason for each step of your working, and those are the kind of things that you need to be saying, okay? Part B, we are being asked to find angle AOC, which is this one. Yeah. And now that we know that this is 71, what we actually have is the angle at the centre is twice the angle at the circumference. So we're trying to find the angle at the centre. We know the angle at the circumference. It's that bow tie. Sorry, it's not. It's the arrowhead one. If I use a different colour, I'm not sure how clear it's going to be, but we're looking at this shape, which is the bow tie theorem, and that is that the angle at the centre is twice the angle at the circumference. So we need to take that 71 and we need to multiply it by 2, which is 142 degrees. Your reason would be because angles at the centre, because the angle at the centre is twice the angle at the circumference. And that's your reason. Again, I'm not going to write it down just because you don't want to watch me write on the screen. But that would be your reason if the exam question asks for it, because the angle at the centre is twice the angle at the circumference. Okay? Yeah, and that's that question done. We found A and B. Like I say, these are quite basic examples. Exam questions typically can be a little bit more complex, but I want us to familiarise ourselves using it with basic examples before we build up to that. Okay, the next one. Here we've got a tangent. We've got, an angle at the centre. We've got a triangle kind of thing going on. And we are being asked to find two angles within that. So the first one is angle BEO, which is this angle here. What we're going to use is the very last one that we went through in the first circle theorem video, is that the two radii form an isosceles triangle. So this triangle here, if I use smaller, this triangle here is actually an isosceles triangle because these two lines are both radius. So they are equal to each other. So base angles in an isosceles triangle are the same. We know one of the angles and we know the other two, so these two angles, so the BEO that we're trying to find, and then the EBO on the other side, they have to be the same size. So we can use that to find out what BEO is, which is the one we're being asked for. So we're going to do 180, take away that 88. First of all, leaves us with 92 degrees. And then we are going to divide that 92 by 2 because we have two angles that are the same size. So we can split that in half, is 46. I am doing this in my head. So if I make a mistake, try to ignore it and just follow the method, but I think I'm right. 180 take away 88 gives us 92, and then we share that between the two angles that we have that are the same size. So each of those angles would be 46. Because, again, if you're asked for your reason, the rule you've used is that 2 radii make an isosceles triangle, and base angles in an isosceles triangle are equal. Part B is asking us to find angle ABE. I'm going to just rub this off. Okay. So what we're being asked to find, ABE, is this angle here going from the chord BE to the tangent ABC. So we're going to use alternate segment theorem. Alternate segment theorem says that the angle in the opposite segment is equal to the angle between the chord and the tangent. This is the angle in the opposite segment. Okay, so if I use a highlighter, this part here is the segment that our chord BE is making. So the angle created on the opposite side is the same as the angle between the chord and the tangent. So this angle EDB is going to be the same as the angle between the chord and the tangent. The only problem is that we don't know what this angle is yet. We need to work that out. What we do have, back to my highlighter, is again this arrowhead shape. So we can use the angle at the circumference is half the angle at the centre, or the angle at the centre is twice the angle at the circumference. So if this angle here is 88, this is the angle at the centre, this is twice as big as the angle at the circumference. So we can half that to find what the angle at the circumference is, which is 44. So this angle here has to be 44. That is using angle at the centre is twice the angle at the circumference. That's the rule we've used. And then using alternate segment theorem, this angle BDE is the same size as angle ABE, which is the one that we have been asked to find. So angle ABE is also equal to 44 because of alternate segment theorem. I am writing this one down just because there's no work in there. We just need to spot that we have alternate segment theorem happening there. Okay. Like I say, alternate segment theorem is often the most difficult one to spot. So that's the one we'll kind of look at the most and will come up most in an exam question. The last one that I'm going to go through, I don't want this video to be another 30 minutes like the last one, is one using the intersecting chord theorem. We're only going to use one of them. The method to use the other one is always very similar. So in this diagram, we have that AE is 49. So this whole length is 49. And then between B and E is 22. And then we have between C and E is 47. And we're being asked to find the length of the chord CD. Now, the theorem says that AE times by BE is equal to CE times by DE. Using what we know, we have 49 times by 22 is equal to 47 times by DE. So we can start to rearrange that and work out what DE is. Obviously, we will then have to use that because that's not what the question has asked us. Just trying to find my calculator because I can't do this one in my head. I should have had it ready. There it is. Okay. So let's just work some of this out. 49 times by 22 is 1078. Is equal to 47 times DE. We want DE on its own, so we're going to divide that 47 over to the other side. 1078 divided by 47 is, oh, it's a really long decimal. Is that right? I thought it might give us a nice number. Is that just wishful thinking? Let's just check it. 49 times 22, 1078. Divide that by 47. Yeah. Okay, I'm going to leave it as the fraction that I'm getting just because I want to avoid really nasty decimals. Gives me 22 and 44 over 47 is equal to DE. Now, that's not what we've been asked to find. What we've been asked to find is this part, is D to C. Is called CD or DC. What we have is this full length is 47. This length is what we've just worked out. This yellow bit is what we've just worked out. And the orange bit is what we need. So to do that, we are going to subtract. We are going to take the length CE, which was 47. We are going to subtract the 22 and 44 over 47 that we've just worked out. Sorry, 44 over 47. 47, not 74. And that gave me 24 and 3 over 47. That is equal to CD, which is what you've been asked for. And that answers the question. I'm still not convinced that it would give you such a nasty decimal, but here we are. If you were to write that as a decimal and round it, it would be 24.1 to 1 decimal place. And that is equal to CD. And that's it, we're done. I haven't put any more examples in. Like I say, I wanted to focus on the shorter ones just for now, the more basic questions, and we will build up to more complex exam questions as we move through this topic. But I hope that helps. And thanks for watching and listening. Have a lovely day.